Now, before we get too far into trigonometry, we're going to review one little trick that you got in geometry, and that's with two very specific types of triangles. In geometry, I gave you that little cheat sheet, and I'll give it to you again in here, but not right away. We're going to see how much you can remember without the use of the cheat sheet. Okay. So in a 45-45-90 triangle, there is a way to get from, as long as you have one side, and you know it's a 45-45-90, you can actually get all the sides. Okay? And it doesn't matter if that side you know is the hypotenuse or if it's one of the legs. Notice on this first example, I've given you this leg that's on the left-hand side that's marked at 3. Okay? So the bottom y, that's actually quite simple in this case. Okay? Because this triangle is most definitely isosceles. And so y also has to be 3. So at this point, do you really need to know the 45-45-90 cheat sheet to be able to solve? No, we could do it easily enough on our own doing what? Let's say we forgot the cheat. Pythagorean theorem, right? Let's say we forgot the cheat, right? So we would use Pythagorean theorem, because I'll show you that, you know, this actually works, and that's not correct. It would be equals. Okay. And so 3 squared, because here's where you put your legs, right? 3 squared equals hypotenuse, which in this case is x squared, right? And so we got what? 9 plus 9 equals x squared. What's 9 and 9? 18 equals x squared. Well, I don't know what x squared is. I want to know what just x is. So we take the square root, crucify the square root of 18. Now I know your calculator can give you that decimal, but we're in advanced math, so we're not going to go with decimals necessarily. We're going to go with exact answers. And I would like simplified exact answers. And we'll go with what most people considered simplified here, which means anything that can be taken out of that radical is taken out. Does anything come out of this radical? Meaning, can I separate this in any way? I could do 6 times 3, right? I could do 1 times 18, but that doesn't really get me anywhere. Or I could do 9 times 2, right? Those are the possible factors that would help us. Which of those is probably going to be the best one to choose? 9 and 2. So the square root of 9 times the square root of 2 is the same thing as the square root of 18. I just chose to write it a different way. And so why would we choose these two instead of 6 and 3? Yeah, because 9 is a perfect square, right? So we got 3 square root of 2 is this side. So now, once we've worked through this one, maybe you can now remember the quicker way of getting to that hypotenuse if you know the leg. Because let's see if there's any relationship between these legs and the hypotenuse. Of course, this is something we'd have to test out and prove if we really wanted to make it solid. But I think we all know that to get from here to there, remember all those little loops I used to give you on those cheat sheets? What do you have to do? Multiply by square root of 2. And what if I want to go in that direction? Divide, right? Divide by square root of 2. Is everybody clear that if I take 3 square root of 2 and divide by square root of 2, I actually get 3? Everybody see that? Right? If I have 3 square root of 2 divided by square root of 2, right? These just cancel, and I'm left with 3, right? Okay. So that pretty much right there is the cheat for the 45-45-90. Okay. Any questions on that one? There's probably a couple you could ask at this point. Yeah, we'll see if they come up then. Well, why don't you go ahead and try that one right now on your own. I'll walk around and see how you're doing. All right, as I was walking around, I did have a good question, and that was, why does Pythagorean theorem work? And I'm saving that one. I'm keeping that one in the back pocket for a little bit, because that one I guarantee will come up later. Because there's hundreds and hundreds of proofs for Pythagorean theorem. All right, this one right here. I bet you a lot of you said, oh, x is 7, because you got going a little bit too fast, right? But x in this case, well, you just got to make a triangle 180 degrees, right? So don't get going too fast. And of course, if you want to, you can just use the cheat. You don't need to go find anything, and that's why this is so good. Because the square root of 2 is about 1.414-ish. And so if I multiply by that, do you agree I'm making the 7 bigger, right? If you multiply by 1.4, it's going to make it bigger. Does that make sense to make the hypotenuse bigger than the leg? It does. And let's say if he said if I wanted to, I could have done it that way and done Pythagorean theorem. It would have worked. Not a problem. Okay. Any questions? So as you can see, sometimes these triangles show up in other objects. And so we've got 6 square root of 2, we've got a 45, a 90, we got a congruent marks. Okay, so I know this bottom one's 45, 45, 90, right? Now somebody just said, so's the top one. How do we know that? Are you using the because it looks like it defense? How do you know it's a square? Well, aren't all 4 sides congruent rhombus or rhombi? So how do we know? Well, I can make a rhombus that shares the 6 square root of 2 line if you'd like. The 45 doesn't quite get it for you. Yeah. Well, that would prove the triangle's congruent. Yeah, we could do it that way. We could prove triangles congruent by side, 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 because you've got this side, and this one is, what's that property again from geometry? Reflexive, right? It's congruent to itself. So you can do it that way. Or it is a rhombus that happens to have a right angle. And if it's a parallelogram, the opposite one also has to be a right angle because it's a parallelogram. Okay? And so yes, they are the same, but you didn't really know why. Okay? You got to think about that. Don't use the because it looks like it defense. So that is a right angle up there. So what you might want to do is just kind of look at this one here as just a 45, 45, 90. And then we have to make it smaller, right? Because we're going from hypotenuse to a leg. And so we'll divide by that 1.414-ish, which does that. And so 6 square root of 2 divided by square root of 2 is just 6. So be careful. I could have very easily asked you for the area of this, the perimeter of this. I could have asked you lots of questions. Well, that is the last example, I believe, that is on your notes for the 45, 45, 90. Do you have any other questions concerning that? Okay. I still believe there to be a pretty good one. That is really small. Whoops. "30, 60, 90 is another one of them that basically people went through there and said, wow, this pattern happens every time. So all I need is 1. A lot of math is what's the minimum I need to be able to do stuff. Okay? And here we know it's a 30, 60, 90 and we have one of the sides, one of the legs. Okay? X is the hypotenuse, Y is the other leg. Well, there's rules to get around this thing as well. Again, I'm going to give you the cheat sheet eventually, but I want to see how much you remember on your own. There are a few in here that have a huge advantage over the rest of you because they just had this. Okay? So we'll see. I know they know it. Or at least we'll pretend they know it so that they're not put on any pressure spots. So we've got across from 30 is 5. Will 5 be the largest side, the medium side, or the smallest side in this triangle? It's got to be the smallest, right? Largest being the hypotenuse, and then Y in this case is going to be then medium, right? Kind of in between the two. Does anybody remember any of the paths? How to get from there to there, or how to get from here to there? Anybody remember? Because they got to get bigger, right? Anybody happen to remember it? I think I heard somebody say it. Which one is it? Do you remember? I'd say, yeah, very good. Multiply by 2 is the top one. We basically double it, and so it's 10. So in other words, when I go from the 5 to the Y, I have to multiply by something that's less than 2, right? Because if I multiply by something that's more than 2, I'm going to make it bigger than the hypotenuse, which is unacceptable. Okay? This one's a little bit harder. Yep. Perfect. Multiply by the square root of 3, which I believe is 1.8 somewhere. And so it is less than 2, right? And so this would be 5 square root of 3. Well, that's very helpful. That saves us a lot of time. Okay? And that's what that is. What's the minimum? I went from knowing one side to knowing them all very quickly. No Pythagorean theorem needed. Worked out very nicely. Okay? Any questions on number 1? Okay, I think it's safe to say I can hand out the cheat sheet now. Because you know them. And it has both sides, 45, 45, 90, and 30, 60, 90. Don't get too comfortable with it. This is just a little crutch for you for a little while. And it will get taken away. And trust me when I say, in about a week, knowing this is going to become incredibly important. All right, so we got our 30, 60, 90. Why don't you go ahead and give this next one a shot and see. That's small too. There you go. Give that one a try. Maybe just give the next couple a try, and I'll pause it, and then we'll get it started back up. Looks as though everybody had a chance to attempt those, so let's see how we did. So here we've got across from 30, and I'll be honest with you, that's probably the best one to know because you can get there very quickly. And so here's 9, so I got to get there, and I've got to get there. And y should be the biggest, right? It's the hypotenuse. And so that's where you multiply by 2, so that's 18. And this we multiply, we've got to make it bigger, by square root of 3. So 9 square root of 3. One question that sometimes gets asked, and not really the one I was looking for, is there a way to get from here right to there? Well, yeah, there is. And you can make that rule for yourself. I just think that rule gets a little bit more complicated. Okay? So I think these two rules here are pretty easy. And obviously, if you go in the other direction, you just divide by square root of 3. And if you go this other direction, you divide by 2. Right? You can make this other rule if you want, going from across from 60 to the hypotenuse. That's completely up to you. Okay? I just think it gets a little more confusing. Okay? Any other questions? And then in this one, we end up in a slightly different, kind of like we did in the last one. We put it in a different figure. Okay? And what we put it in a square that you figured out last time. What are we looking at here? The big picture. Equilateral triangle. How do you know it's equilateral? Well, and equiangular, probably, right? How do we know that? And how do we know the bottom one is 60? Very good. Because that just says 30 over here. Oh, yeah, the whole triangle's got to be 180, huh? Or you could say this one's 90, right? Because that's a linear pair right there. So either way, that's 30 down here, right? So yeah, this is 60 overall. So it is equilateral or equiangular, whichever way you want to talk about it. Lots of ways you could get to these answers. What I would probably suggest that we do, though, is let's focus maybe on getting x first. And then we'll review your knowledge of this little segment in the middle where x is. Okay? So 26 is our hypotenuse of the one I just traced in red. And so is there a rule to get from hypotenuse to across from 60? Have I given you that rule? Let's put it that way. No, I haven't. But which one did I tell you is very helpful to have? Across from 30. So we might as well get there first. Okay, so this is the first time we actually went in that direction. I have to make it smaller. Okay, to get from 30 to here, I have to multiply by 2. So to undo that, we divide by 2. Or multiply by a half, whichever way you want to say it. And so this is 13. Okay. Now that we're at 13, we have to get from there to across from 60. So I have to make it a little bit bigger. But it better not get bigger than 26. Okay. And to do that, we follow our rule, which says multiply by square root of 3. So this one right here is 13 square root of 3. Any ideas on why? There's lots of ways you could answer this question right now. I've left it pretty wide open. I think most of you know the answer, but can you explain why? Because the it looks like it defense is not acceptable. Well, let's start with the answer. What is y? 13. You're right, it is 13. Can anybody tell me a good reason for it being 13? There's lots of answers to this question. Yes? Okay, side angle side. Where do we see side angle side? Which side angle side? I agree, you can do that. But we didn't know 13. Right, but then I'm going to compare it to one I don't know. But I do know this one, that one, and this angle. Right? There's your side angle side. It's an equilateral. You told me that at the beginning. So if this side's 26 over here on the right side, this has to be 26 over here if it's equilateral. How do you know it's divided by 2? But how do you know that that segment cuts it in half? It's a perpendicular bisector. It's also a median. It's also an altitude, and it's also the angle bisector. Because we're in an equilateral triangle. It's all four of those at once. Very good. That's another way you could explain it. Okay. But because it looks like it is not acceptable. Do you have any other questions? Well, if you don't, then you should be able to handle this next problem I'm going to give you with very, very great ease. Please solve this particular problem for x and y. I want the exact answer in simplest terms. Again, we will pause this for a second so that you have a time to work on it. All right, keep in mind that we are in advanced math, and so exact answers in simplest form is what we're looking for. So we've got 1 as the hypotenuse, and you're going to see this triangle again. Okay, this one's not going to go away. This very specific one. So we have a hypotenuse of 1, and I told you to get across from 30 because that's kind of probably the quickest way to get there, and we have to make it smaller. So you divide by 2 or multiply by a half, right? Same thing. And so what do you get? 1/2, agreed? Okay. So how do I get from here to there? I got to make it bigger, right? So multiply by. So what does that look like? 1/2 times the square root of 3. Yeah, square root of 3 over 2. Very good. Because this is really over 1, right? You could write it that way. And when you multiply, you go straight across, right? So square root of 3 over 2 is that side. Very good. You are going to get very, very tired of those numbers. You're going to see them a lot. Okay. Oh, you'll find out. The question was why. Trust me, you'll find out. One person in here knows. And then you should have no problem with this one then. The hypotenuse being 1 is going to prove to be incredibly important. Again, I want exact answers, simplest form. Let's take a look. Oh, 1's hypotenuse. We know this is isosceles, so whatever we get for x, we get for y, right? So we just really have to do one of them. And so it doesn't matter which one you go to, so we'll just kind of do this one. And how are we going to get there, though? We have to make it smaller. We know square root of 2 is kind of that special number for the 45, 45, 90. So if I multiply by square root of 2, I'm actually going to make it bigger. And I don't want to do that, so we're going to divide by square root of 2. So in other words, it's 1 divided by square root of 2. That is unacceptable in here. Radicals in the denominator are not okay. How do we take care of that? Technical terms would be helpful, but as long as you know exactly what's happening, that's good too. We're going to multiply by a very special form of 1, right? Because you can always multiply by 1 whenever you want. For example, I could multiply by 10 over 10 right now if I felt like it. But is that going to get the radical out of the denominator? No. So we have to decide, well, what is the easiest form of 1 that I can multiply by here? It's called the conjugate. Okay. And what is that very special form of 1 that's going to help me very quickly here? Yes? Yeah, square root of 2 over square root of 2. Now, why that works is basically what I just did is I squared that bottom. Right? I took it times itself. That's why it works. Okay, so this top is 1 times the square root of 2, which is square root of 2. And square root of 2 times the square root of 2 really means square root of 4, right, which happens to be 2. Okay, so this one here is square root of 2 over 2. and square root of 2 over 2. Okay. You're going to get very tired of those numbers as well. You'll be writing them down hundreds of times in the next couple of weeks. Yes? Oh, great question. Why can't you have radicals in the denominator? That was basically just something that someone decided along the way that it's not simplified. Very true. I have huge issues with simplification. And the one example I always give is if I ask you to approximate this answer, which one are you going to approximate better? Will you approximate for me the square root of 99 better, or will you approximate 3 square root of 11 better? Which one are you probably going to get closer for me? Which one, if you had to go into your head right now and give me an approximation for that, you agree they're the same, correct? Which one are you probably going to be able to give me a better answer for? Square root of 99, right? So why is 3 squared root of 11 simplified? Did it make it simpler for you? No. Okay. I have issues. I don't just go with the flow. Okay. But this one, because these numbers show up so much, we are going to follow what they say, which is get rid of the radicals in the denominator. And a lot of times, as someone, again, can attest in here, in calculus, we just leave them down there because they kind of go away. We do certain things that kind of makes them go away. And so we don't care if they're down there. Because we're in calculus and we cannot follow the rules at that point. Any other questions? So the really good question would have been, like, what happens if you have that radical in the bottom? Maybe you could have seen that coming. Okay? And you just use your conjugate and get it out of there. Okay? Anything else?